Course, Hydrogen Storage and Transportation Logistics. Podcast, Hydrogen Logistics Specialist, Essential Competencies and the Future of the Profession. Welcome to the podcast episode of today. Today, we will explore the realm of hydrogen and its increasingly significant role in the energy transition. Our focus will be on a captivating facet of this revolution, the individuals who will spearhead it. We will examine the profession of hydrogen logistics specialist, who they are, the essential skills required, the career trajectories this specialization offers, and the future prospects for this rapidly evolving field. When contemplating the hydrogen economy, our minds frequently drift toward futuristic technologies. Advanced electrolyzers generating green hydrogen, quiet fuel cell vehicles, or extensive pipeline infrastructures. While these visions are indeed inspiring, we often overlook the critical developments occurring behind the scenes. A significant amount is transpiring. As an energy carrier, hydrogen must be transported efficiently and safely from the production site to the consumption point. This is where hydrogen storage and transport logistics specialists assume a vital role. This profession demands a blend of technical expertise, strategic insight, and operational proficiency to tackle the unique challenges presented by this remarkable element. The significance of hydrogen logistics. The core of the hydrogen supply chain. A hydrogen logistics specialist embodies the roles of engineer, strategist, and manager. Their principal duty is to design, implement, and optimize the comprehensive hydrogen supply chain, from production and storage to transportation and final distribution to the customer. This task is complex as hydrogen's unique characteristics, low bulk density, flammability, and diffusivity, present distinct challenges. The low density necessitates substantial storage space for even minimal energy quantities in gaseous form, while its propensity to rapidly permeate materials demands specialized, highly airtight solutions. In practice, the hydrogen logistics professional will source and demand analysis. This will identify the locations of hydrogen production and consumption, considering quantities, purity, and timelines. It encompasses comprehensive market analysis, demand forecasting across various sectors, transportation, industry, energy, and strategic flow management to align production with fluctuating demand. This is accomplished through forecasting and simulation tools, which analyze historical data and external influences. He was evaluating the most effective storage methods. He was determining whether to store hydrogen in compressed form, CgH2, within pressurized tanks, or in liquefied form, LH2, within cryogenic tanks. He would also assess more advanced carriers, such as ammonia, NH3, or liquid organic hydrogen carriers, LOHC. Each option presents its own advantages and disadvantages, influencing cost, safety, and efficiency. For instance, LH2 provides high bulk density, but necessitates extremely low temperatures and is prone to evaporation losses, referred to as boil-off. CgH2 is more straightforward to utilize but demands significantly larger tanks. Logisticians must take into account the specifics of the project, whether it involves a bus refueling station in an urban area or a large-scale seasonal warehouse at a wind farm. Transport routes and methods were designed by selecting among pipelines, most efficient on a large scale, yet costly to construct and vulnerable to hydrogen embrittlement. Road tankers, CgH2 or LH2, adaptable but with limited capacity and elevated unit costs. Maritime transport, LH2 or ammonia tankers, essential for global trade. Or rail. This often necessitates multimodal strategies, integrating various transport modes to optimize time, cost, and carbon footprint throughout the entire route. For instance, hydrogen may be conveyed through pipelines to a regional hub and subsequently transported by tanker truck to the customer. Risk and safety management. This is a paramount aspect, particularly in hydrogen logistics, where it is essential. Logisticians must identify potential hazards such as leaks, fires, collisions, and hydrogen embrittlement of materials, and establish comprehensive preventative measures alongside emergency response plans. This encompasses the design of physical security measures, operational procedures, and collaboration with local emergency services. Optimized costs and efficiency. He consistently endeavored to reduce operating costs, OPEX, and capital expenditures, CAPEX, throughout the entire supply chain while maintaining its reliability and sustainability. This involved assessing the return on investment in new technologies, enhancing energy efficiency in compression and liquefaction processes, and minimizing empty runs in transportation. Competencies, career paths, and professional perspectives. To address these challenges, a hydrogen logistician must possess a highly diverse skill set, technical and engineering knowledge. This encompasses a comprehensive understanding of hydrogen's properties, including reactivity, density, and behavior at both low and high temperatures, as well as an in-depth knowledge of storage technologies, which involve various types of pressure vessels from Type 1 to Type 4, and transportation methods. Proficiency in process engineering fundamentals, such as compression and liquefaction, along with an awareness of the effects of hydrogen on materials, such as hydrogen embrittlement, is also crucial. Knowledge of standards and regulations. A logistician must possess expertise in international regulations, including the ADR for road transport, the IMDG code for maritime transport, and the RID for rail transport. Familiarity with local technical and safety standards is equally crucial, encompassing regulations pertaining to the designation of explosion hazardous areas, ATEX, and the certification and inspection requirements for hydrogen equipment. Analytical and optimization skills. The capacity to analyze data, model and simulate supply chains, evaluate risk, and optimize costs is essential in this role. The logistician employs contemporary tools such as warehouse management systems, WMS, and transport management systems, TMS, along with artificial intelligence and the Internet of Things, IoT, to predictive maintenance, dynamic route optimization, and process automation. Soft skills. Primarily, these encompass project management, from conception and implementation to operation, effective communication with diverse stakeholders, ranging from engineers to management and emergency services, critical thinking and problem-solving in unexpected situations, along with adaptability and receptiveness to change. This is essential as the hydrogen industry evolves at an exceptionally rapid pace, and collaboration within interdisciplinary teams is a routine aspect of the work. How does one become a hydrogen logistician? Generally, this role necessitates an individual possessing an engineering degree in environmental, chemical, logistics, energy, or mechanical engineering. An increasing number of universities provide specialized courses and modules designed to prepare candidates for this profession. Expertise may also be gained through industry-specific training and certifications, particularly those pertaining to safety, EEG, ATEX, ADR. Professional development in this sector is an ongoing endeavor, necessitating the continual updating of knowledge as technologies and regulations advance. The career trajectory can be varied. Typically, individuals start in roles such as process engineer, logistics specialist within energy or gas firms, or supply chain analyst. As experience and specialized knowledge of hydrogen accumulate, one may progress to managerial roles, hydrogen project manager, or logistics director in organizations engaged in hydrogen production, transportation, or distribution. The potential for advancement is virtually boundless. Where can you find employment? The job market for hydrogen logistics specialists is expanding swiftly. Potential employers include energy companies, hydrogen production firms, such as those in the chemical industry and steel production, manufacturers of hydrogen technology, transport and logistics companies, consulting firms, pipeline and terminal operators, and the mobility sector, including FCEV manufacturers and operators of hydrogen bus and train fleets. Additionally, there is an increasing demand in the research and development sector, where hydrogen logistics experts contribute to the commercialization of innovative solutions. What makes this profession so promising? The industry of the future. You are engaged in a sector with significant growth potential and a tangible impact on the decarbonization of the global economy. The International Energy Agency, IEA, forecasts that hydrogen could satisfy as much as 10 to 20% of global energy demand by 2050. This indicates stable employment and continuous development opportunities. High earnings, specialized knowledge, and distinct skills are greatly esteemed in the labor market, resulting in competitive salaries. Real impact. You play a significant role in shaping a sustainable energy future, aiding in the reduction of emissions and combating climate change. Dynamic environment. Ongoing technological advancements, the implementation of innovative solutions, and the lack of monotony render this profession one characterized by challenges and perpetual learning. International perspectives. An opportunity to collaborate with global partners, engage in international projects, and work across the globe. Hydrogen logistics is a field for the courageous, open-minded, and technology-driven individuals who aspire to make a significant impact on the future. It transcends mere employment. It is a mission, establishing the groundwork for a global, sustainable, hydrogen-based economy. The demand for such experts continues to grow. We cordially invite you to participate in the Hydrogen Storage and Transport Logistics course. If you believe that the future of hydrogen aligns with your aspirations and wish to explore these captivating technologies further, we have an ideal opportunity for you. We warmly invite you to participate in our extensive course, Hydrogen Storage and Transport Logistics. This course presents an opportunity to acquire vital skills and enter the job market within one of the most innovative and dynamic industries. It is not merely theoretical. We prioritize practical experience and the genuine challenges you will encounter in the field. Our objectives are well defined. We will equip you with an extensive understanding of hydrogen logistics, encompassing storage, transportation, safety, risk assessment, end-to-end supply chain management, and environmental considerations. You will acquire a theoretical foundation while examining the latest market trends. Enhance your practical skills in emergency response, logistics system planning, and process optimization. You will engage with real-world case studies and simulations, enabling you to apply your knowledge in practice and make decisions within a secure environment. Cultivating pro-ecological attitudes within the framework of the hydrogen economy is essential, as environmental awareness remains our foremost priority. We will instruct you on constructing sustainable supply chains that not only reduce emissions but also enhance corporate social responsibility. What will you gain upon completing the course? You will not only comprehend hydrogen safety regulations and standards, but also possess the ability to analyze risks and formulate emergency procedures. You will learn to distinguish between storage and transportation technologies, and most importantly, you will be equipped to design a comprehensive storage system and select the optimal transportation method for a specific scenario. You will grasp the interconnection between logistics, emissions, and carbon footprint, and you will be capable of applying contemporary warehouse and transportation management tools, including WMS, TMS, IoT, and AI systems. In simple terms, you will be prepared to proceed. How will we collaborate? Our course represents a dynamic amalgamation of mini lectures and multimedia presentations designed to impart essential theoretical knowledge. Engage with infographics and worksheets that enable you to apply your knowledge practically and reinforce it by addressing real-world challenges. Case studies and simulations that present authentic industry challenges, enabling you to develop decision-making skills under pressure. Collaboration and facilitated discussions are essential, as optimal learning occurs through dialogue and the sharing of experiences with fellow participants. In addition to podcasts and refresher quizzes, which will assist you in retaining essential information and evaluating your knowledge in a user-friendly manner. Comprehensive information regarding the course program, dates, and registration is available on our website. Visit us at www.academiawodoru.edu.pl and become part of the future cohort of hydrogen experts. That concludes today's episode of our podcast. We appreciate your attention and encourage you to enroll in our course, which will pave the way for an exciting career in the hydrogen industry.
Funded by the EU. The views and opinions expressed are those of the authors only, and do not necessarily reflect the views and opinions of the European Union or the Foundation for the Development of Education. Neither the European Union nor the Foundation for the Development of Education are responsible for them. All results developed within the framework of the project, professionals and their skills in the hydrogen sector are made available under an open license, CC BY-SA 4.0 deed. They can be used free of charge and without restriction. Copying or processing these materials in whole or in part without the author's consent is prohibited. When using the results, it is necessary to cite the source of funding and its authors.